Hello everyone, and welcome back to the Fluctus Channel. Developed in the 1950s, the Boeing B-52 is a strategic bomber with a large payload capacity and an exceptionally long operational range. Originally designed during the early years of the Cold War, it quickly became a cornerstone of U.S. strategic deterrence. The United States military has deployed the B-52 in multiple conflicts, including the Cold War standoff, the Vietnam War, and more recent operations in Iraq and Afghanistan. Its ability to fly up to 9,000 miles without refueling, while carrying up to 70,000 pounds of ordnance, makes it one of the most capable bombers ever built. Because of its adaptability and proven performance, the B-52 has remained in service for nearly 65 years and is expected to continue flying for several more decades as part of the U.S. Air Force's long-range strike capability. The B-52 is capable of carrying both conventional and nuclear weapons, a task that requires precision and coordination by a specialized team of munitions airmen. These teams are responsible for ensuring that each weapon is safely transported, properly configured, and accurately mounted onto the aircraft. Initially, weapons are moved from secure storage areas to the hangar bay using bomb lifts and specialized loading vehicles known as jammers. Once positioned near the aircraft, the bomb bay doors are manually opened. Airmen then use folding ladders to access the mounting points inside the bomb bay, where they physically align and secure each munition. This process requires careful attention to detail, as proper alignment and attachment are critical for both safety and mission success. Boeing originally designed the B-52 to carry multiple bombs simultaneously, allowing it to deliver significant firepower over a wide area. While effective for large-scale bombardment, this configuration limited flexibility, as the aircrew could not easily change weapon types once airborne. To address this limitation, the aircraft was upgraded with a system known as the Common Strategic Rotary Launcher, or CSRL. This advanced system allows the B-52 to carry a variety of missiles, bombs, and precision-guided munitions within a single internal platform. More importantly, it enables the crew to switch between different weapon types during flight with minimal effort, significantly enhancing mission flexibility and adaptability. The main advantage of the rotary launcher system lies in its ability to hold multiple types of munitions and deploy them in a controlled, sequential manner. This allows aircrews to respond to changing mission requirements without needing to return to base. However, loading the CSRL is a time-intensive process, often taking up to 11 hours to complete. Once fully loaded, the launcher is carefully secured onto a transport trailer and moved toward the aircraft. The process requires precise coordination between ground crews to ensure safety and accuracy during transport. For installation, the rotary launcher is positioned directly beneath the B-52's bomb bay. Using specialized lifting equipment, it is raised into place and securely mounted inside the aircraft. This step requires exact alignment to ensure proper integration with the aircraft's internal systems. Once the launcher is installed, the bomb bay doors are carefully closed, completing the loading process. At this stage, the aircraft is fully armed and ready for mission deployment. As the bomber reaches its target area, it releases its payload with precision, leaving visible trails as munitions descend toward their objectives. As part of maintaining operational readiness, the U.S. Air Force conducts regular B-52 scramble exercises. These exercises are designed to ensure that both air crews and ground personnel can respond quickly and effectively to real-world scenarios. Readiness is a critical component of strategic operations, and these drills help maintain the ability to deploy the aircraft at a moment's notice. A B-52 scramble involves the rapid preparation, fueling, arming, and launch of the bomber for immediate mission execution. During such operations, time is a critical factor, and crews must operate with speed and precision. Ground personnel work simultaneously across multiple systems, while flight crews prepare the cockpit and mission parameters. This coordinated effort ensures that the aircraft can be deployed quickly in response to emerging threats or mission requirements, maintaining the strategic advantage of rapid response capability. Under normal conditions, preparing a B-52 for flight can take approximately 1 hour, largely due to the time required to warm up its engines. However, during high alert scenarios, a much faster method is used. Airmen employ small, controlled explosive cartridges to ignite 2 of the 8 engines, initiating the startup process. This technique, known as the cartridge start or cart start, significantly reduces preparation time. Using this method, the B-52 can be ready for takeoff in under 10 minutes, providing a critical advantage in situations where rapid deployment is necessary. Throughout this process, continuous communication is maintained between air defense authorities, ground crews, and pilots. Mission details are updated in real time, allowing pilots to adjust their plans accordingly. This seamless coordination ensures that the aircraft is fully prepared for departure within a minimal time frame. Before takeoff, the aircraft often perform what is known as an elephant walk toward the runway. This maneuver is designed to maximize the number of aircraft launched in the shortest possible time. During an elephant walk, B-52 bombers taxi in close synchronized formation, maintaining tight spacing as they move toward the runway. Pilots carefully coordinate their movements to ensure safe separation while demonstrating their ability to operate in close proximity under high-pressure conditions. The number of aircraft involved can vary depending on operational requirements, but it is common to see multiple B-52s participating in these formations. Elephant walks are often conducted during training exercises, readiness drills, and large-scale demonstrations, showcasing both the operational capability and coordination of bomber forces.
Go here. You're Shrek.
The U.S. Air Force has expanded the role of the B-52 beyond traditional bombing by using it as a launch platform for advanced hypersonic systems such as the Boeing X-51 Waverider. The X-51 is an unmanned experimental scramjet aircraft capable of reaching speeds of Mach 5, or approximately 3,300 miles per hour. Unlike conventional aircraft, the Waverider uses the compression lift generated by its own shock waves to remain airborne at extreme speeds, marking a major advancement in hypersonic flight technology. Unlike standard munitions stored within the bomb bay, the X-51 is mounted externally on the wing of the B-52. Despite this difference, its launch sequence closely resembles traditional airborne deployment methods. Once released, the X-51 stabilizes using a set of aerodynamic fins located at the rear, allowing it to maintain controlled flight at hypersonic speeds.
Okay, can you see it?
I can. More left, more left.
Okay.
Okay, I got it now. We're fine.
These experimental systems are part of ongoing efforts to unlock next-generation capabilities in speed, range, and precision. The X-51 program consisted of 4 major test flights, each contributing valuable data. The first test in May 2010 reached Mach 5 and sustained flight for over 200 seconds, although it fell short of its planned duration. The second test in June 2011 also achieved hypersonic speed, but ended prematurely due to engine failure, resulting in the vehicle crashing into the Pacific Ocean. The third test in August 2012 successfully reached the targeted 300-second flight duration at Mach 5, but control issues caused by a fin malfunction led to another crash. After design improvements, the final test in May 2013 achieved a sustained flight at Mach 4.8 for 210 seconds, marking the longest air-breathing hypersonic flight at the time. The program concluded with valuable data that continues to influence modern hypersonic weapon and aerospace development. Building on this legacy, private companies are now pushing the boundaries of hypersonic flight. One example is Stratolaunch, which recently conducted a successful test of its Talon A vehicle. During this operation, the massive rock carrier aircraft, equipped with 6 engines, launched the Talon A over the Pacific Ocean. The test vehicles separated cleanly and accelerated through transonic and supersonic speeds, following a flight profile similar to historic experimental aircraft like the X-15. While the Talon A achieved high supersonic velocity, it likely did not exceed Mach 5. The current version is designed to be expendable, although future variants such as the TA-2 are expected to be recoverable and reusable, marking a significant step towards sustainable hypersonic testing. Alongside these advancements, the preparation and maintenance of traditional munitions remain a critical component of B-52 operations. Within the U.S. Air Force, specialized munitions squadrons are responsible for assembling and maintaining bombs used by the aircraft. In one exercise, airmen from the 2nd Munitions Squadron constructed 30 non-explosive BDU-50 bombs. Each component was carefully inspected before assembly, ensuring strict adherence to safety and operational standards. Airmen followed detailed checklists, aligned components precisely, secured caps, and attached stabilizing fins designed to guide the bomb during descent. Not all munitions remain serviceable, and damaged bombs must often be refurbished.
Well, he has a kid now, so.
In such cases, the U.S. Navy and Army collaborate to restore unusable bombs to operational condition. Each bomb is inspected to determine whether it can be repaired, with damaged coatings being the most common issue. Repairable bombs are placed on a conveyor system where they undergo a full restoration process, including removal of old coatings using high-pressure water jets, application of new protective layers, curing, and final preparation for redeployment. Advanced robotic systems are often used in this process to ensure precision and consistency. From hypersonic flight systems to traditional bomb assembly and refurbishment, the evolution of B-52 capabilities reflects a continuous pursuit of precision, adaptability, and operational efficiency. Each advancement builds upon decades of engineering and testing, expanding the role of the aircraft far beyond its original design. The B-52 is no longer just a bomber. It is a platform for innovation, capable of delivering both conventional and next-generation technologies. From launching experimental hypersonic vehicles to deploying precision-guided munitions, it continues to adapt to the demands of modern warfare. And as technology evolves, so does the mission pushing the limits of speed, accuracy, and strategic reach. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.